focus on simplifying roots other than just square root. Although we'll continue to simplify square roots. Okay? And so some of these notes may seem to be a little long-winded. I want to make sure that you have an opportunity to get enough examples down to understand what's going on. Question, Danielle?
How many points is the review? 10, you said?
No, each of those top ones, don't they say next to them, +1, +1?
No, the Unit 2 review, the review sheet. I think you said that that's 10 points?
That would be 10 separate. I grade that myself.
Okay.
That's not part of the notebook check.
Okay.
Okay, sorry we recorded all that conversation. So for any real numbers A and B and any positive integer n, if a to the n is equal to b, then a is the nth root of b. What's that? That's the definition, yeah. Since 2 to the 4th is equal to 16 and negative 2 to the 4th is equal to 16, so both 2 and negative 2 are 4th roots of 16. Since there's no real number x such that x to the 4th is equal to negative 16, negative 16 has no real 4th root. Since negative 5 is the only real number whose cube is negative 125, and negative 5 is the only real cube root of negative 125. So what we're saying is when there's an even power, the negative number has no real even roots. Okay? But with an odd root, negative 5 times negative 5 times negative 5 is a negative 125.
Right.
And positive 5 times a positive 5 times a positive 5 is a positive 125. Then to get the cube root, the third root of a negative 125, there's only one answer. It's negative 5. If I do the cube root of a positive 125, there's only one answer. It's a positive 5. Okay? So with odd roots, there's only one possibility. Okay? So the following chart sums up this concept. Are we ready for the chart, or are we still copying?
Are we supposed to copy that?
I think so. The chart that sums up this concept is say the type of number. So positive number, the number 0, and negative numbers. So positive number is going to have two nth roots. When n is even, it's going to have one real root when n is odd. 0 is going to have only one real root either time. And when looking at negative numbers, there will be zero real roots when n is an even number, and one real root when n is an odd number. So the fourth root of a negative number, there's 0 real roots. The sixth root, the square root, the 10th root, there'll be 0 real roots there. But if I have an odd number, like the 5th root, 3rd root, 7th root, 9th root, all the odd numbers of a negative number, then there will be exactly one real root when we do that. Okay? Okay, let's find the real roots for these two examples. The cube roots of 27, negative 64, and 1 over 729. The cube root of 27. What's the cube root of 27? Okay, because 3 times 3 times 3 is 27. So you're correct. The cube root of 27 is equal to 3. So what's the cube root of negative 64? Can we have a cube root of a negative number?
Yes.
Yeah. Right? A negative times a negative times a negative will give me a negative number, right? So what times itself will give me 64? Louder?
4.
4. And so the answer here is
Negative 4.
-4. Okay? And then 1 over 729. So when you do a fraction, you can break them up, top and bottom. So what's the cube root of 1? Someone might have answered, I didn't hear you.
1.
1. And what's the cube root of 729? 9? Is that true? 7, 9, yeah. I would agree with that. So you get 1/9. Okay? So now, 4th roots.
Hold up, wait a second.
Oh, I'm sorry. What's that?
Will you just wait a second?
I will.
Thank you.
Am I waiting so you can just copy it down, or am I waiting because you have a question you want to ask?
You're waiting so that I can copy it down and understand it at the same time?
Okay.
No, I can't understand it if I'm just writing.
Don't
it
have a
down.
conversation with him, just copy.
I'm ready.
You're done now?
I am.
Okay, do you have any questions on what you copied down?
No.
You followed what I was saying?
Mhm.
Okay, so moving down to example 2, the 4th roots of 625, negative 1,000, no, I'm sorry, 1/10,000, and 16 over 81. Okay, so the 4th root of 625. So in other words, what times itself, times itself, times itself, times itself is 625? 5. Okay? The 4th root of a negative .0001, which is 1/10,000. Louder? It's not possible to get real numbers, is it? So there is none. So we'll just say that's an imaginary number. Okay? Now if they wanted the I value, we could say, well, it's 0.1i, right? 1/10 would be the 4th root of 1/10,000. Okay? So it'd be 0.1i. But that's not what they're asking for in this case. And so then 16
2.
over 81, the 4th root of that is going to be the 4th root of 16 over the 4th root of 81. So we can break that fraction into individual 4th roots. And so, Audrey, what's the 4th root of 16? Times itself, times itself, times itself, times itself is 16. What times itself, times itself, times itself, times itself is 16?
4.
Okay, let's try it. What's 4 times 4?
16.
Times 4? 64. Times 4? 256. So it's not, see how big it got fast? So it's got to be a smaller number, right? What is it, Caleb? 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So there are, the 4th root of 16 is 2. What's the 4th root of 81? 3. Okay? So we get 2/3. Now I know that you could do most of this, all of this on your calculator, but the point we want to get across here, and the reason I'm not saying get your calculator out and do it, is because I want you to realize what's happening with these roots to give us the numbers we're getting. I don't want you to realize, oh, I just plug this in my calculator and it tells me to think how to think. I want you to realize what's happening. And the 4th roots are the 4th roots because that number times itself 4 times will give you that original number. Okay? Okay, radical sign is used to indicate a root. The index is the number up here where the n is at. The radical symbol is that square root looking symbol that we normally talk about. And underneath the radical symbol is what we call the radicand. Okay, well, let's copy that now. All right, so when a number has two roots, a positive root is called the principal root. And the radical sign indicates the principal root. Okay? So the principal fifth root of 32 is written as the fifth root of 32. Reality is, in this example, an odd root, there's only one real root anyway. What the key of this is, when number has two roots. This one only has one anyway. Find each real root. So what's the cube root of negative 1,000? What's the cube root of negative 1,000? So can I get the cube root of a negative number? Yeah, and it's going to be a negative number, right? And Matt's saying the cube root of 1,000 is 10 because 10 times 10 is 100 times 10 is 1,000. So it's going to be negative 10. Okay? Find each real root. Can I find a real root for the fourth root of negative 81? No. I can't. So I would say again, this is imaginary. Okay? It's imaginary root. Now, the fourth root of 81 is 3. And so if I wanted to, I could say that's 3i. But it's not a real root. All right. Can I move on? So the property of the nth root of a to the n is a is less than 0 for any negative real number. What's that? No, this is the absolute value of a. I'll let you copy this down. It's really hard to talk about this concept as Mrs. Mills and I were discussing it yesterday. It really is hard to talk about. It's easier to show you in examples. Hopefully you'll understand better then. Okay? So I'm just going to let you copy this down, then we're going to jump to the examples, and hopefully that'll make more sense what that's saying. All right. We want to simplify this radical expression. Okay? And so we're going to actually, I'm going to show you a rule that we're going to talk more about tomorrow. I think this is easier done if we talk about them a little bit right now. This can be broken down as in the square root of 9 times the square root of x to the 10th. Okay? And what's the square root of 9? 3. And x to the 10th. If I take the square root of x to the 10th. Well, if I look at it this way, I really have x to the 5th squared. Right? X to the 5th squared is the same as x to the 10th. Right? Multiply the exponents. What's the square root of something squared? Itself. So the square root of x to the 5th squared would be x to the 5th. Pause. What this other stuff was saying that we wrote down is that x to the 5th, if x is 2, we get 2 to the 5th, which is 32. Do you agree with that? If x is a negative 2, then we get negative 2 to the 5th, which is a negative 32. Do you agree? Well, we started out with x to the 10th. What kind of number does that have to be? Louder? If I take a number and I times it by itself 10 times, what kind of a number do I have to get? A positive, right? If I take a negative times itself 10 times, I'm going to get a positive number. If I take a positive times itself 10 times, I'm going to get a positive number. So the key is, we started out with a number that has to be positive, and now we've rewritten it as a number that maybe is not positive. Right? And so because of that, we have to throw in absolute values. We have to throw in absolute values. So here's the rule. If we start out with an even power, and when we take the root of it, we end up with an odd power, then we have to use absolute value symbols. Okay? So in this case, in part B here, I have I have an odd root, don't I? And so if I have an odd root, these could be odd numbers, they could be positive numbers, they could be negative numbers. The odd root will take care of it. So in this case, I'm not going to worry about absolute values. So what is the cube root of a cubed? A. And what's the cube root of b cubed? And so the cube root of a cubed b cubed is ab. Okay? The cube root of a cubed b cubed is ab. So whenever these numbers match, they cancel out, and we're just left with whatever that letter is, or that number.
That was making me confused.
Yeah, I wanted to get that out of there so that you could see part B didn't have all their other stuff with it. Okay? Now this one I'm going to do just a little differently. With the same philosophy that I used here when I said whenever this number and this number match, we just get left with that letter. I'm going to break my x to the 16th up into x to the 4th times x to the 4th times x to the 4th times x to the 4th. And my y is already to the 4th, so I'm going to leave it like that. Okay? Now, do I still have 16 factors of x there?
Yes.
Isn't that what I started with? X to the 16th means x times itself 16 times. Right, Liberty? X times itself 16 times is x to the 16th. And so x to the 4th, x to the 4th, x to the 4th, x to the 4th still gives me x 16 times, doesn't it? But by writing it this way, I can realize that, hey, these all match up. You agree? And even the y to the 4th matches up. And so what happens when I take the 4th root of x to the 4th, I get x. The 4th root of x to the 4th, I get x. The 4th root of x to the 4th is x. The 4th root of x to the 4th is x. And the 4th root of y to the 4th is y. Are there any others left inside the radical sign? No, in this case they all worked out perfectly. And so I'm left with now x to the 4th times y, and I really don't need the dot. So I get x to the 4th y. I do not get 4x if that's what I heard someone say. Okay? I get x times x times x times x times x. I think I said it 3 times. Okay? And so that's x to the 4th. Okay? questions on that? I want to just clarify one more little thing before we move on. And I give you your assignment, which is not what you saw a glimpse of before. Because we bounced around so much, that other had review problems in it that you may or may not have done anything with them yet. So they wouldn't be review, they might be learning, and that's not going to go well. So one thing I want to clarify. The square root of 4 is equal to what? 2. Okay? The principal root, the square root of 4 is 2. That's different than when you start out with a problem like this. Because in this scenario, do we know what x is? No. Not until we solve. And some of you might instantly say, oh, I know what it is. Only because you're solving in your head right away. In this scenario, we don't know what x is. And so to find x, I square root both sides. But that x is being squared. And I don't know if that x was a positive number or a negative number. When I squared it, I'm still going to get a positive, don't I? So in this setting, I always get a positive or a negative, and then whatever square root of 4 is. What is that? 2. Okay? So two different questions going on here. This one simply says, what is the square root of 4? Square root of 4 is 2. This one says, what could x be that when I square it, I get 4? Well, that could be a positive 2, or it could be a negative 2. Does that make sense? How they look the same, but they're slightly different, what they're really asking. And so when you start out with a problem like this, that's going to give us 2 answers. When you start out with a problem like this, that's going to give us 1 answer. There's only one number that's the square root of 4. It's 2. Okay? Your assignment today, then, is going to be the odds up to 35. So lesson 7-1, 1 through 35.